All right, in this lesson we're going to practice the skill of writing chemical equations. This is a difficult skill, especially when we get to balancing those chemical equations, so it will take a little bit of practice to get used to. In chemistry, we need to be able to write a chemical equation given a word sentence and vice versa. The general formula for any chemical reaction is the reactants on the left. The reactants are your starting material, and the products on the right. Those are your new materials that you've formed. This arrow indicates the course of the reaction. So you have some reactants, they react together, you create products. There's a couple of different important terms here. A word equation includes the names of the reactants and the products. Hydrogen plus oxygen gives us water. That's an example of a word equation. Just the names. An unbalanced or a skeleton equation, you can use either of those, includes the formulas of the reactants and the products, but it does not include the balancing coefficients used to balance the mass. That's a fancy way of saying that the number of atoms on either side is not equal. This is the same equation as what's written above. Hydrogen plus oxygen gives us water. This is hydrogen plus oxygen gives us water. This tells us the states of our reactants, both of these are a gas, and the state of our product, which is a liquid. A balanced equation uses coefficients to balance mass. This word coefficient, which I'm going to highlight in green, refers to the numbers to the left of our formulas. This tells me that I have 2 hydrogens react with 1 oxygen to produce 2 waters. The coefficient is the number that goes to the left. The reason we use coefficients is because we have to make sure that we have the same number of atoms on the reactant side as the product side. I'm just going to write a little note here. I'm going to say the number of atoms on the reactants, it really should be in on the reactant side, I suppose I could write, but the number of atoms in the reactants equals the number of atoms on the product side. This coefficient multiplies the formula that it sits beside. Each hydrogen has 2 hydrogen atoms. This 2 multiplies this hydrogen molecule. So in total, on the reactant side, we have, if I'm looking at the number of hydrogens, I have 2 times 2 equals 4 hydrogens. I'm just going to highlight this 2 in green here because we're multiplying by this coefficient. We had 2 hydrogens, we multiplied by 2, so now we have 4 hydrogens total. We also have 2 oxygens. If there is no coefficient, we assume that the coefficient is a 1. It's not like there's 0 oxygen molecules, there's just 1 oxygen molecule. So we have 2 oxygens and 4 hydrogens. On our product side, within the molecule of water, of H2O, we have 2 hydrogens and we have 1 oxygen. Now that we've placed a coefficient of 2 to the left of our water molecule, we can multiply both of these by 2. So each water molecule has 2 hydrogens, 1 oxygen. We have 2 water molecules, which means in total we have 4 hydrogens and 2 oxygens. That's the same number of hydrogens and oxygens as we have on our reactant side. So we have not created or destroyed any atoms. We have the same number of atoms on this side as we do on this side. In the previous lesson, we talked about how chemical reactions can have a change in energy. This reaction happens to be exothermic, meaning it will give off energy, give off heat. However, we don't have a change in mass. Change in energy, but not a change in mass. If you were reading this reaction and you're trying to change it into a sentence, this is what it's saying. 2 moles of hydrogen react with 1 mole of oxygen to produce 2 moles of water. The words react with are the same as this plus here. So I'm going to highlight that in blue. React with is the same as this plus. And the word to produce is the same as this arrow. When we have the word here 2 moles, a mole is a chemical amount. So we have 2 moles, or you could even say molecules of hydrogen react with 1 molecule of oxygen to produce 2 molecules of water. You could replace the word mole with molecules. A mole is a group of molecules. It's a specific number of molecules, but it's kind of like how a group of donuts is called a dozen donuts. That's 12 donuts. A mole is a specific number of molecules. We're going to do some examples of writing an unbalanced chemical reaction equation. We're not going to do any sort of fancy balancing yet. We're just going to write out what is reacting with what in a chemical equation. I'm going to highlight our reactants in red, our products in purple, and some keywords in green or blue. Solid magnesium metal reacts with, I'm choosing blue, hydrochloric acid, which is the same thing as aqueous hydrogen chloride, to produce aqueous magnesium chloride and hydrogen gas. I'm going to change this into green for the sake of this. The words react with means a plus, and to produce is our arrow. The things I've highlighted in red are the things that react together. Things I've highlighted in purple are the things that we end up with at the end. We can write out the formulas for these things. Solid magnesium metal. Magnesium metal is Mg. They're telling us it's a solid, so we can give it that solid state. Reacts with, we'll give a plus sign here, hydrochloric acid, aqueous hydrogen chloride. Hydrogen and chloride together, HCl. To produce, we put a reaction arrow in, aqueous magnesium chloride. Magnesium chloride is MgCl2. Make a better 2 there. And the reason it's not just MgCl, if you go back to your ionic compound building, magnesium has a charge of 2+, chloride has a charge of 1-, so magnesium chloride has to be MgCl2, and hydrogen gas. Hydrogen is one of those elements that when it's by itself is diatomic. I have your data booklet here on a different tab. Just want to show you, this is the table that will tell you whether or not something will exist. When these are elements, all of these ones on this table here, astatine, bromine, chlorine, fluorine, hydrogen, iodine, nitrogen, oxygen, phosphorus, and sulfur, they have to exist as molecules. So hydrogen can't just be H, it has to be H2. So whenever you're forming an element, check to see if it's in this box. If it's not in this box, you can assume it's by itself, just like this magnesium is by itself. It doesn't need an Mg2, but the hydrogen does. This is our unbalanced chemical equation. We can move on to the next one. Aqueous sodium chloride, and aqueous silver nitrate. This and here is our plus sign. React to produce solid silver chloride and aqueous sodium nitrate. We have sodium chloride. They've told us it's in an aqueous state, which means it's dissolved in water. And we are reacting it with aqueous silver nitrate. Silver nitrate is AgNO3, nitrate is NO3 minus, silver is Ag plus. We know it's aqueous, so give it that little AQ. Reacts to produce solid silver chloride. That's AgCl. It gets the solid state because they've told us it's solid. And we're also producing aqueous sodium nitrate. If you were to watch this reaction happen, both of these happen to be clear solutions. Aqueous means we've dissolved it in water. Neither sodium chloride or silver nitrate have much of a color to them. It would be clear solutions, homogeneous. You mix them together, you're going to end up forming a solid that suddenly appears when you mix these two solutions. This solid, to revisit a word we talked about in the last lesson, is our precipitate. This is a precipitate. That green arrow makes it look like there's a reaction. I'm just going to put a label underneath. This is our precipitate. This is a solid that forms from two solutions reacting with each other. Working backwards, this is our unbalanced chemical equation. We can write the word equation, or what's happening. So we'll take a look at our ingredients here. We have magnesium, I'm just going to highlight our reactants in red. I'll write them down in a minute. And a couple key words and stuff in different colors here. And then based on the colors in my sentence, you'll know what each word came from. Okay. This is solid magnesium metal. So I'm going to write solid magnesium metal. You could just write solid magnesium, but be specific. Solid magnesium metal. This plus sign can be written as reacts with or and, but I'm going to say reacts with. Solid magnesium metal reacts with this compound here. This compound is in the aqueous state. You can write aqueous strontium nitrate, or perhaps a solution of strontium nitrate, reacts with aqueous strontium nitrate. That's the name of this ionic compound. To produce, switching colors to green, because that's going to indicate our change from the reactants in red to our products in purple. Solid magnesium metal reacts with aqueous strontium nitrate to produce. Our first product is strontium metal. We can put our state solid strontium metal. And aqueous magnesium nitrate. This is a skill. It takes time, especially if you're unfamiliar with the element symbols and you still need more practice naming ionic compounds. When you come across a compound like this, it might take you some time to come up with the name strontium nitrate. And practice is the best way to do that. There's a lot of good practice questions here. I'm sure that your teacher has a key for these, or maybe they were assigned as homework. I'd encourage you to try some of that out. In the next lesson, we're going to talk about balancing chemical equations. So taking what we just did with writing the unbalanced chemical equation and then making sure that we have the same number of atoms on both sides of the chemical equation.